Good try. Okay, here we go. Now we're going to go into absolute value. Okay, absolute value bars. Remember those? What does absolute value mean again? The distance from 0. Okay, so the inequality, the absolute value of x is less than 3. So the distance from 0 is less than 3. So it's going to be, like if you were on a number line, it could be 3 higher or 3 lower, yes? So when you have a less than sign, here's the key piece right here. A less than sign with absolute value is an and inequality. Remember yesterday the difference between and or? So a less than with absolute value is an and statement. If we think back to absolute value when we solved absolute value equations, they always had two answers, the positive and the negative. Remember that? We have to do the same thing here. So on this problem, the absolute value of m plus 2 is less than 11. Because I see the less than sign, I'm going to split this into 2. M plus 2 is less than 11. And m plus 2 is greater than negative 11. The first one you leave, the second one you flip the inequality and you make it negative. Everybody follow what I did so far? Okay, let's solve for m. On the left, I should subtract 2. M is less than 9. And on the right side, minus 2. M is greater than negative 13. If I want to push this back together, put the numbers in order. Which one's smallest? Negative 13. And then 9 is out bigger, yes? Okay, now look at this. Between m and negative 13, the alligator jaws are eating m. So in my statement, the alligator jaws should eat m. Well, good. Matches Miss Hoff said it should be a less than sign. Safe. Between m and 9, the alligator jaws are eating the 9. So make them eat 9 here. Gotta graph it. No. You'll be okay. All right. Compared to 9, open or closed? Open, left or right? Don't go off of that. Don't go off of that. M is less than 9, so you got to shade to the left. Okay. Then when we open this, we go negative 13. Open or closed? Open. Left or right? Why? It's greater than. Now, we need to shove these together. Is there a place where our two shadings overlap? Yes. Okay, so if I put them in order, negative 13 and 9, open or closed? Open. And where do they overlap? In the middle. In the middle. So this is also part of our answer.
All of it?
Yes.
Wait, no, just the last one or those two others?
Just the last one where he pushed them together.
When it's a problem like this, you know they meet in the middle.
Do you know they meet in the middle?
Yeah, it tells you the problem.
Oh, it does?
Yeah.
Let's go to the next one. The absolute value of y minus 1 is less than negative 2. Remember, it's less than, yes? Less than is a and statement. So y minus 1 is less than negative 2. And y minus 1 is greater than 2. To solve on the left, add 1. Y is less than negative 1. And if I add 1, y is greater than 3. Okay? I'm going to graph. Okay. If I put my graph at negative 1, open or close circle? Open. Do I shade to the left or the right? Okay. at 3, open or close circle? Open. Do I shade to the left or the right? What's my problem here? They don't overlap. But it's an and statement. Why can't I just put -1 and 3 and shade in the middle? Always graph. Always graph. It's no solution. You're going to hate me for a minute. Are you ready? You could have known it was no solution without doing any work. Why?
The first one was like on the right side. In the parentheses, the
Absolute value bars.
Oh, it can't be a negative.
Yeah, okay, so you're saying the absolute value of something is less than -2? Absolute value is always positive, yes?
Yeah.
So a positive number is less than -2? Never. That's never a possibility. Now, what if they said absolute value is greater than -2? Then you could, yes? Okay. Less than or equal to are always and statements. On the flip side, which page comes next? I think I totally did this wrong. That's okay. We'll do this here. A recent survey showed 65% of young adults watch online video clips. The margin of error was within 3 percentage points. Find the range at young adults. I'm not worried about finding the range. We're just going to write the absolute value inequality. Every single time that you have to write the absolute value inequality, you have absolute value bar, x minus, and you'll have to fill this number in. Then you got to put a symbol in here, and you'll fill in this number as well. Okay? So this is going to be a number. This is going to be a number. This is a symbol. Inside the absolute value bars is your goal or the center, the middle, like what you want. The number at the end is your give or take, the margin of error, or the change. So in this problem, if we're going to write an inequality for this one, we would say the absolute value of x minus 65, close your absolute value bar, symbol. What word are you looking at?
I was just guessing.
Okay.
If it's not a negative, pretty good guess.
No.
It'd be a positive margin. Oh, within.
Within. Ooh, we used that word yesterday. Within. Within. 3%. Does within mean more than 3 or less than 3? Equal to?
0 to 2. No.
Equal to? Within?
Yes.
What did we say yesterday? Within equal to? Between is not. Within is. Okay? I need my margin of error to be within 3 percentage points. I need it to be 3 or less. That's all they're asking you to do on that. All I want to do is practice that. And we're going to skip the next one because it's dumb because it's got a 0 in it. Okay, you do not have to solve that. Okay, on the flip side, if it's greater than or greater than and equal to, it's an or statement. So with absolute value, it is crucial you pay attention to what your beginning symbol is. That determines your and or your or. So if we look at this, the absolute value of 3n plus 6 is greater than or equal to 12. So we say 3n plus 6 is greater than or equal to 12. Or 3n plus 6 is less than or equal to negative 12. I got you. Yep. On the left, let's solve. Are you already ahead of me? subtract 6, 3n is greater than or equal to 6, divide by 3, n is greater than or equal to 2, or n is less than or equal to -6. On or statements, don't push them together. It's going to stay an or statement. But we got a graph here. Important number is 2. Open or closed? Closed, left or right? Right. Important number is -6. Open or closed? Left or right? With an or statement, do they have to overlap? No. So your final graph would show a -6 and a 2. Closed circles on both, correct? And your wings are shaded, which is typical of an or statement, right? Typical 97% of the time. Okay? Let's go down to the bottom one. The absolute value of r minus 6 is greater than or equal to -5. With a greater than or equal to symbol, it's an or statement. So we write r minus 6 is greater than or equal to -5, or r minus 6 is less than or equal to 5. If I add 6, r is greater than or equal to 1. Okay? If I add 6, r is less than or equal to 11. So if I throw 1 on here, open or closed at 1? Closed, right or left? Right. Open or closed at 11? Closed, right or left? That's to the left. So if I'm going to shove these together, where do I shade? But it's an or.
Oh, wait, no. Just do one.
Or, how many shadings do you have to have on an or? You only have to have one. If you have 2, fantastic. You only have to have 1. So where is that number line shaded one time? Alexa, say it again. On the wings? You shaded the wings? If I shoved these two on top of one another, where is their shading? Everywhere. What's your answer to this? Infinite solutions. Why? Why?
Because there was a -5.
Yeah, but last time it was a -5, it was no solution.
This one's a greater.
It's greater than. Absolute value means it's a positive number, right? A positive number is greater than -5. When? Always. Always. Okay? In summary, you need to remember this. Absolute value less than or absolute value less than or equal to are and statements. I don't care where you write this down. Absolute value greater than or absolute value greater than or equal to are or statements. So ultimately, these are going to start as absolute value, but then they're going to turn into compound inequalities like you've been doing the last 2 days. Okay? Before you move, write this down. You are starting on page 314. 9 through 41. Odd, da, 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 da. Odd, da, 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 da. Odd. Odd. 9. What's your next odd? Da, 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 da. 11, 13, so on and so forth. Okay? No.